grading, of the homework assignments, and I've been catching up, a little bit lately. So when you go to your grade book, you should see the grades for some of the homework assignments. I don't think I have graded everything yet, but I have graded the one from last week, the one that is due last Thursday. That has been graded already. So you might want to take a look at your score. Most people got 30 out of 30 because it was not really exactly very difficult. A few people got minor points dinged because of minor mistakes. So you might want to take a look at yours, especially if it says please read my solution with the please in italic. That usually means please read my solution and make sure you understand that. Okay. There are very few people getting that, but the very few people getting that should definitely review the material before the next examination. This is week 9 or week 10. This is week 9. Is 10 already? Okay. So we'll have about a week or so, before the next exam. And once again, I will give you a practice test, just so that you know the kind of questions that will be asked. This time there won't be any pre and post conditions. It will all be, tracing. But this time there will be a lot of subroutine stuff, parameters, return values, and stuff like that. So that's going to be, kind of important. Do you guys have any questions? Yes?
Do you have pre and post condition 2 graded yet?
Nope, that has not been graded yet. I'm kind of working my way back. So.
Okay, I'm just making sure because I don't have it on here.
Mm-hmm. It's kind of cool that you guys can check it on your cell phone, because Moodle works, on the cell phone. Have you guys tried D2L on your cell phones? Does it work okay?
Yeah.
They have a mobile thing.
They have mobile, or you can choose to use the same plug as
So D2L has a mobile version.
I have problem using some of the menus on D2L.
Mm-hmm. D2L has a lot of JavaScript stuff, so you have to enable JavaScript. And I think, even for the mobile version, do they have frames in frames? No?
I haven't tried it.
Because Moodle doesn't do frame in frame. That's one thing that makes it a little bit easier to navigate. So let's go. Is that this class? Yep, I think so. All right. So I graded parameters for sure, and I think I graded one other homework assignment. I cannot remember which one. There's a new homework assignment. No, this one is due today, so I cannot possibly have graded that one. I think it's subroutine 1.
Subroutine and array.
And array 1. Yeah, array 1 is kind of interesting. Almost the entire class, got everything right. There were a few people who made calculation mistakes. So the loop is right, they exit at the right point of time, except the values, in the arrays are wrong. So they got some minor points deducted, not really a whole lot. There were only about 3 or 4 submissions that are like completely wrong, and those are kind of more alarming cases. But for the most part, the entire class got 30 out of 30 or 28 out of 30 just for minor deductions. No big deal. The subroutine 1 is about the same thing. So I think the class as a whole is getting the concepts. So that's good. What I'll do next is I will talk about the solution for the parameters homework assignment, and then we'll talk about the new homework assignment, which is return values. Do you guys want to talk about the new one first or the old one first?
Old one.
Old one first? Okay. So let's take a look at parameters. And take a look. Yep, go ahead.
How do you merge cells when you deallocate?
How do you?
You merge the cells.
Oh, it's Alt-O-E-M. Alt-O and then E and then M. I will show you. I will slow down and show you how to do that.
Yeah, because I tried to do it through the actual bar menu and it was shaded out.
Yeah,
the
format.
You want format? Same here.
Okay, I'll show you guys how to do it. I'll slow down right there. You don't really need to do that. You don't actually have to do that. You can just just X out, because the X's will extend to the next columns. So as long as I see that you're deallocating the right number of columns, that's fine.
Okay.
So you don't have to merge it. But it's kind of nice to know how to do that sort of tricks. So we'll go ahead and do that too. First thing is to resize the menu. Take a look at This particular homework is all about parameters. Okay, do we know how to pass parameters, passing by value and also passing by reference? So that's the focus of this assignment. The actual operation is fairly pointless. Yep, go ahead.
It was actually a question about the return value, so I figured I could wait on that till
Okay.
we can talk about it.
Yeah, the return value is the focus of the current homework assignment, the one that's due next Thursday. So we'll talk about that next. So remind me about your question when we talk about return values. Okay. And the first, in this case, the precondition is, okay, I've got to save it first. And we can save it to today's folder. That's not it. Today's folder. And the first line that is outside of the precondition is easy. There are no global variables in this case, so there's nothing to say about the precondition. The first line that is outside of the definition of any subroutine is line 22. That's the only line that is outside of the definition of subroutines. We're going to invoke the subroutine R, which is this one here. It only has one local variable x. That means we have to reserve one return line number column. It is not returning a value. That's why we don't need to use return info. And we have to allocate another column for local variable x for that particular invocation. As a local variable, x starts with an unknown value. The return line number is post because there are no additional lines after line 22. Then we go into the subroutine starting on line 19. Line 19 is going to assign a value of 21 to x. X goes from unknown to 21. Okay. Then we proceed to line 20. Line 20 is going to invoke subroutine S, which means we have to reserve another column for return line number. This time we have to reserve one column for x, parameter x, one for parameter y, and it also has its own local variable I. So this time we have to reserve 4 columns altogether. The return line number is line 21 because line 21 logically follows line 20. Parameter x is passed by value. We can tell it is passed by value by 2 different indicators. One is the right arrow. The other one is when you look into subroutine S, x is passed by value. So that means what we do is we look at the value of x, which is column C, and then just make a copy of that to the other one. So we just say this parameter x has a value of 21 because it is a copy of parameter of local variable x of subroutine R. Let me just stop here and make sure that everybody understand why column E also has a value of 21. Because the point of confusion is on line 20. Because on line 20 you see x on the left-hand side, you also see x on the right-hand side of the right arrow. But those 2 x's refer to different items. The left-hand side is always referring to the variables or global variables in the current subroutine. The current subroutine is R. So this x here on the left-hand side refers to the refers to the variable x of subroutine R, which in our trace is column C. The x on the right-hand side of the right arrow refers to the parameter of the subroutine that you are invoking. That would refer to by value x in subroutine S. And that's column E, which is what we are trying to set up. Are there any questions about this part? No? Okay. Now we have to deal with parameter y. Parameter y is passed by reference. You can tell by the double-sided arrow here, as well as the word by ref in subroutine S. So that means we are not giving y a particular value. We are making y an alias of the x that belongs to subroutine R. So that means y is going to become an alias of column C in this case. I, being a local variable of subroutine S, is just unknown to begin with. And that's how we set up those 4 columns when we invoke subroutine S. Are there any questions about this step? When we invoke subroutine S, this is how we set up the 4 columns. Is that good? Okay. Once we set up the columns, we go into subroutine S starting with line 13. Line 13 says we want to compute the sum of x and y and then assign the result back into I. What is x? X is a bival parameter. It has its own value of 21. Y is an alias of column C, which at this point also has a value of 21. So we have 21 plus 21 being the right-hand side. The left-hand side is I. I gets updated to 42. Then we move on to line 42. We move on to line 14. Line 14 is invoking subroutine T, which is the last subroutine. And that's why we have to set up everything else here. We have to set up the return line number, as well as all the parameters and local variables. Subroutine T has two biref parameters, x and y, and one local variable T. So we have x, y, and T here. Variable T is a local variable, so it starts with an unknown value. X and y, on the other hand, are both passed by reference. And when you look at line 14, I use the x that belongs to subroutine S to pass to the x of subroutine T. Subroutine X,
T.
parameter x of S is on column E. So that's why this one becomes an alias of column E. Are we doing okay so far with this step? Yep.
So it's not column C.
It is not column C.
What if you referred to column C?
Well, it has no exposure to column C, so that would be marked as wrong. I have not decided how many points to deduct, but conceptually it is not, column C. So this one is actually column E, but do we understand why it is referring to column E? Kind of? Yep.
Yeah, well, as you explained it, you only can see the left or the rightmost X, so that would be what it has to refer to.
Yeah, but it also has to do with this X here is referring to the X of subroutine S. The X of subroutine S at this point is column E.
Right.
So that's why there's no exposure to this local variable X that belongs to subroutine R, which is all the way back here. So that's why we have homework assignments. If you get dinged a few points in homework assignments, it makes a very very small dent in your overall score, because all homework assignments add up to 20% of your final score. And we have so many homework assignments, it just kind of dilutes everything. If you have been doing well with homework assignments, getting dinged a few points in one single homework assignment, it's not going to make it's not going to make a big deal. But if you have one question wrong in a test, that's a lot of points. So that's why we have these homework assignments, to make sure that we have the correct understanding of the mechanisms. Okay, let's take a look at parameter y here. Parameter y is specified by I. This I is the local variable I of subroutine S, and that is column G. So y is an alias of column G. That's how everything is set up when you invoke subroutine T, which is the swap subroutine. Are we doing okay so far with the setup of column I, J, and K? Yep.
What about our return line number?
The return line number is going to be line 15 because the invocation happens on line 14, and line 15 follows line 14 logically. Okay. Now we go into the subroutine T, which is the swap subroutine. We already know what it does, so we'll just go ahead and do it, starting on line 5. And let's go ahead and split the screen so we can scroll a little bit to the other side. So, on line 5, we copy the value of x to t. X refers to column E. Column E has a value of 21. T now has a value of 21. On line 6, we copy the value of y to x. Y refers to column G. Column G has a value of 42, and that's why X, which refers to column E, now gets a value of 42. Is that okay? Okay. In other words, column I and column J do not get updated. Only what they refer to will get updated. That's the key of passing by reference. And then we move on to line 7. Line 7 says we want to copy the value of t to y. T has a value of 21. Y refers to column G. Column G now has a value of 21. And I did it in the wrong cell. There we go. Are we doing okay so far with this code? Then we move on to line 8. Line 8 is the end of a subroutine. We always have to deallocate all the columns that we allocated for this invocation. So this is how you do it. Okay, let me just explain the keystrokes because you cannot see the keystrokes. You can see what I do on the screen, but you cannot see what I do on the keyboard. I press the shift key down and then press the right arrow 3 times. So that's how you select multiple cells. You can do the same thing with a mouse. Okay, you can definitely do the same thing with a mouse. I just do everything on the keyboard, because it's easier for me to do it on the keyboard. The next step is to press Alt-O, for format, and then E, which is where's E? E stands for merge cells, and it is grayed out. That is interesting. And this time it doesn't let me do it.
It doesn't do it on the other.
Hmm?
I tried another one of the documents from Moodle, and it also doesn't do it there, but I can do it in a new document.
You can do it in a new document. That is just strange. I wonder why it doesn't let me do that.
Is this the newest version of OpenOffice?
Yeah, this is Libreoffice, which is the same as OpenOffice, and it's 3.3.1, which is pretty close to the latest version. I have been using this approach for a long time. I wonder why it's not letting me do it now.
Because on the name you showed it.
O, E, and then the M is grayed out. So the columns are protected for some reason. Let me see if this is it. Okay. Let's not track changes anymore. Oh, okay, we don't want to do that. Okay, let's turn back to default formatting first, and that didn't help. Very interesting. And it might have to do with the track changes thing that I turn on. So let me see if I can do this. I will just go ahead and accept all changes, and then turn off track changes, and then do the same thing here. 4 cells, and now it let me merge. So that was it. It doesn't make any sense, because when I turn on track changes, it doesn't let me do merge cells. But as soon as I, get rid of track changes, it let me do it again. So for your homework assignment, don't turn off track changes. Just use enough access to cover the entire thing, and you'll be fine. The other way to do it, okay, let me show you the other way to do it, which is more consistent with the notes, is to copy all 4 cells. No, that's not what I want. Okay, copy and paste onto line 8. And then what you can do is you can use character formatting. So go to, where's character formatting here? I guess it's still in cells. Go to font effects. And then you can use strike through. Just use a single strike through. That works too, because you're striking through the column headers to indicate that that column is no longer in use. So this way you don't have to mess with merging columns and stuff like that. That does not seem to work. Okay. Any questions about this part? Okay. So after line 8, we have to remember to use the return line number to return to line 15. And when we're back to line 15, we have to finish this last operation before we get to the end of subroutine S. We have to find out what is X. X has its own value, which is 42 at this point, and I has its own value, which is 21 at this point. 42 plus 21 is 63, and we want to put 63 back into Y. Y does not have its own value. Y is an alias of column C. So that means, at this point, column C is going to be updated to a value of 63. Then we move on to line 16. I think we don't need to split the screen anymore. So now we move on to line 16. On line 16, we have to deallocate the columns. So I'll use this approach this time. Copy and paste the header of those particular columns. Go to Format, Cells, Font Effects, and then change strike through to single strike through or double strike through. It doesn't matter which one you pick, as long as it is clear that these columns are deallocated at this point. And that tells me, the return line number tells me we have to go back to line 21. So now we are back to line 21. Line 21 by itself is also the end of a subroutine, so we have to do the same thing here. Look up the return line number. It tells me to go back to post. Next line to execute this post. Then we have no need for column B and column C anymore. And then we just indicate those two columns are no longer useful. And do exactly the same thing. Change the strike through to single. And that's the end of it. Are there any questions about this trace? Okay, now if you don't get it entirely right, with the homework assignment, it's not a big deal because the points you will get deducted is not going to be that significant for your final grade. But it is important to make sure that you understand why the program behaves this way. Are we doing okay so far with the mechanisms of passing by value and passing by reference? Is that okay? Any questions about this particular assignment? Yep.
On line 15, y is supposed to get the value of x plus I, but you have 6300 in the x column.
On line 15, you mean in the trace? Row 15 of the trace?
Yeah.
Okay, let's highlight that line and see what we are doing here. Okay, this is row 15 of the trace, and coincidentally, we are also executing line 15 in the program. In the program, on line 15, we are supposed to compute the sum of x and I. This is x of subroutine S, which is a parameter passed by value. This is I of subroutine S, which is a local variable, of subroutine S. The parameter x has a value of 42 at this point. I has a value of 21 at this point. 42 plus 21 is 63, so that part is pretty easy. And we are going to use that to change y. Now, y of parameter y of subroutine S is passed by reference. It is an alias of column C. So that's why when you update y, you are changing whatever it is whatever is referring to. In this case, it's referring to column C, and that's why column C is updated to the value of 63. Okay. Generally speaking, one thing you can check is if you see a parameter that is passed by reference, the first thing is, it has to be an alias of something. And the second thing is, since its existence all the way to the deallocation, there should be no updates in this column. Okay, that's one of the properties of a pass by reference parameter is you don't change the parameter column itself, you change whatever the parameter refers to. Okay, so in this case, because parameter y refers to column C can potentially be changed, in these lines in the execution of these lines, but the parameter itself does not get changed. Are we doing okay so far with this stuff? Okay. So let me save this first. Make sure it is all saved into today's folder. And if you think that you might have gotten it wrong at certain places, you just need to look at my solution and compare that to your solution, and just to make sure that you understand how passing by value and how passing by reference work, because that's the whole intent of this homework assignment. Okay. If there are no questions about parameters, we'll move on to the return value homework assignment, which is your current homework assignment due next Thursday. Okay, I made a mistake here because I forgot to upload the file. And the file is sitting on the computer in my office, so that's not going to be very helpful today. It's basically just using return values. This particular program has no parameters. No pass by value parameter, no pass by reference parameter, no global variables, and no local variables either. The whole thing is about return values. Yep.
For return values, once you get a value for your return value, you change. It's like you're recopying the line, right? It says you've got the line number, and it says something like return. Something
When you
other.
execute the return statement, you copy the return info cell, and then you replace the question mark with the value that you're returning.
And then on the next line, then where do you go after that?
Well, that's a good question because it depends on the programming language. In most programming languages, when you execute a return statement, the next line is the end of the subroutine. You have to get out of the subroutine right after you say return something. That's the normal behavior of most programming languages. But in this class, most of the time we just pretend that you continue to execute anyway. And that's a good point. Maybe I should address that today when we talk about return values. But before that, let me see if I can go back and go back to my Office machine and see if I can access. I don't know. How do I access my Office machine from here? I can bounce off a few points to get back to it. Okay, let me see if I can do it from here. So I have to go back to my home machine first. Here, I can go to my Office machine. Oh, it's not connecting.
Is your machine on? Is your machine on?
My Office machine is on. It's just not establishing a connection to my Office machine at home. P. Is it is supposed to be listening. Oh, that's not working. It's using port forwarding, so can I see the IP address from here? Well, I guess I have to go back to my Office to re-upload the file, because I cannot access it from here. I can still give you an example to illustrate, what your homework assignment looks like, so that will still be useful. So let's go to Calc again and just work out the example, from here. It's already open here. Okay, your homework assignment looks like this. Okay, not quite as simple as this one, but it's similar. So we'll just go ahead and have 5 as a subroutine, and all it does is to return 5. And define sub, and then we'll have another subroutine called 3, and all it does is to return the value of 3, and define sub. So without making this really complicated, this is all that I will do, is to invoke 5 plus invoke 3, and then fix the indentations like that. All right, so based on what we have learned already at this point about return values, can we find out what this program is going to do? I think we should be able to do that. Okay, so I'll just go through this as an example so that it's just a refresh of what we talked about on Tuesday already. So let's go ahead and do it. All right, starting with line number. The precondition, there's nothing to say because there are no variables and no parameters of any kind in this program. We start execution on line 7. Line 7 is going to invoke the subroutine. Well, we don't know. Okay, I'll let you guys decide what to do on line 7. Line 7 ultimately has to print out something. Can I print out that something now? No, because in order to compute what I'm supposed to print out, what do I have to do first? Okay, find out what it is, and it's the result of adding 2 things. Well, can I perform the addition now? Nope, because we don't know what is on the left-hand side or the right-hand side of the addition. So that means I have to resolve, invoke 5 first, and then I have to resolve what is invoke 3. The normal way to do things is from left to right. So we will invoke the subroutine 5 first in this case, and then we'll invoke the other subroutine, which is 3. So let's go ahead and do that. I will go ahead and invoke 5 first. And to invoke 5, I have to use return info instead of return line number. Why is that the case? Because if I use return line number, all I can say is to return back to line 7. It doesn't tell me what else on line 7 I have to do when I get back from subroutine 5. So that's why we have to use return info, because return info doesn't tell me just that we have to go back to line 7. It also says on line 7 we still have the print operation not done. This invocation of 5 will supply the value to replace the question mark, and we still have the addition and also the other invoke to take care of on line 7 when we come back from subroutine 5. That's why we use a return info instead of a return line number in this case. Are we doing okay so far with this part? Why only a part of it is replaced by a question mark? Yep.
So only that part of it is there because there's only a single parentheses around invoke 5 instead of double parentheses around both invoke 5 and invoke 3?
No, it's just because you have to do you can only perform one invocation at a time on the same line. So you cannot replace both of the invocations with question marks, because in that case, what are you replace? You cannot find out which question mark is which anymore. So we can only do one thing at a time, and that's why we pick the left-hand side first, because we read from left to right. Okay. Are there any questions about this part? Okay. So once we set up the return info cell, we can go into the subroutine. We don't need any additional columns because we don't have any parameters, we don't have any local variables. So we go straight into the subroutine 5, execute the only statement in subroutine 5, which is line 2. Line 2 is a return statement. What a return statement does is quite easy. Okay? All it does is to copy and paste the return info cell, change the question mark to the value that we are returning, and we are done. Okay? Then we go to line 3. All line 3 is going to do is to look up where we are supposed to go back to, what operations are still to be done, and then it will deallocate, in this case, just column B. So we'll do the same trick here, copy and paste return info, and then go to cell format, change the strike out to single to indicate this column is now deallocated. Then we go back to line 7. When we go back to line 7 does not look like the code in the pseudocode anymore. It now looks like the code that we have in B5. Okay, the cell B5 in the trace. This is what line 7 looks like at this point. I'm pretty close to being able to perform the addition, but not quite there yet, because I still have to resolve what invoke 3 is going to return. So that means I have to invoke again. If I invoke 3, I will have to allocate a column to remember where I'm supposed to go back to and what else I have to do on that line. So I'm reallocating column B at this point, because column B was deallocated already on row 6 of the trace. So on row 7, we are actually reallocating it. And when we go back to line 7, the first part is already resolved, and the second part will be resolved as well by the time we get back onto line 7 this time. Then we go into the subroutine starting on line 5. Line 5 is return 3, and all it does is to copy and paste return info, and then change the question mark to the value that we are returning, which is 3 in this case, and we are done with the return statement. The execution of the return statement is just replacing the question mark with a specific value. Then we go to line 6, which is the end of the subroutine. We do exactly the same thing. We just say that we have to return to line 7 after this, and then we deallocate that column. So we just copy and paste the header of the column, and then change the strike out to single. And there we go. We have deallocated the column. But this time when we get back to line 7 now looks like this, because we have both of the invocations resolved to specific values now. There are no more invoke on line 7 as it is now according to B9. And we can perform the addition. 5 plus 3 is 8. We are printing the value of 8. So we can actually go ahead and perform that operation this time. And in the comments column, we just have to say that we are in fact printing the value of 8. And there's nothing else to do in this program. So are we doing okay so far with the concept and the mechanisms of invoking a subroutine that returns a value? There are 2 points of interest in this particular case. The first one is, what do we do when we perform the invocation? When you perform the invocation, you have to use a return info cell to remember what else on that line you have to deal with, along with setting up the parameters and also the local variables that we have to do with any subroutine already. So that's the first point of interest. The second point of interest is, what do you do when you actually execute the return statement? When you execute the return statement, you copy and paste the return info cell. You change the only question mark to the value that you're returning. That should be one and only one question mark. If you see 2 question marks or more, something is not right. If you don't see a question mark, something is wrong as well. And then and when you return at the end of the subroutine, when you return, then you have to go back to the line that is indicated by the return info cell. But one thing you have to keep in mind is that line is now looking like this because the question mark is now resolved. Are we doing okay with the concept of return values? Okay. Now, since you mentioned what do we do after the return statement, that's a very, very good question. So let me show you why it is kind of tricky to answer that question. And I'll show you what most programming languages will do in that case. First, let's save this file into the dates folder. And we'll call that 8 is 3, 5 plus 3. Okay. So when you look at this sample program, obviously it's not very useful because all it does is to add 5 to 3 and print out the value of 8. But it does illustrate the mechanisms of returning values. This is pretty much as simple of an example as anyone can give to illustrate the concept of returning values, because it has no parameters, no local variables, no global variables, no arrays. It's just return values. All right, so this is all done. Now let's go take a look at another program. Okay, I'll just make a new program on the fly to illustrate that concept. I'll call this subroutine post return, to illustrate what happens after the return statement. And all we will do in this case is return a value of 12. Okay, it doesn't matter. But unlike the other subroutines that we have just seen, I will have one more statement after the return statement. It's print, we are here. Okay, and then we have n define sub. And all we want to do in the main program part is to say print, invoke, post, return. Because this is basically the smallest program that I can write to illustrate the point that I want to make. This is something that I have not talked about in the notes, because in this class, you don't have to come up with the algorithms. So it's not a big issue not knowing this particular fact. But it is kind of important when you move on to cisp300. Let's fix the indentations first, and then we'll trace it. Okay. The trace is going to be very, very short in this case, but the important part is, why are we not executing that line? Okay. We'll start with a column for comments because we will print something later on. Then we have line number. There's nothing to say about the precondition. We don't have any global variables. The only line that is outside of the definition of a subroutine is line 5, and that's why we start with that one. Okay, so far it's pretty easy. We have to use a return info in this case because the subroutine we are invoking is going to return a value on line 2. The return info is going to be quite simple too. We will go back to line 5. The only thing left to do on line 5 is to print out the value that the subroutine returns. So that's it. We don't have any local variable. We don't have any parameters to set up. Then we continue execution in the subroutine. We execute line 2. Line 2 is a return statement. We copy and paste the return info cell. We change the question mark to the value that we're returning, which is 12, and that's it. Okay, line 2 is easy. The question is, where do we go now? Okay, now, we have never encountered cases like this. Okay, in all the programs that I have written in this class, of all the programs that we have traced in the class, I always make sure that when you're done with the return statement, we go straight to the end of the entire subroutine. In this case, I intentionally make that it does not. And to basically make you think, what are we going to do next? Are we going to line 3 or are we going to line 4? As it turns out, it depends on the programming language that you're dealing with. In Visual Basic, it will continue on to line 3. In C and C++, and most languages that are derived from C, that would include Java, Perl, PHP, and so on, it will go straight to line 4. Okay, so let me say that again. Go ahead. You had a question.
I was going to say, so in order to make sure that it actually prints we are here, you need it before the return statement.
Correct. Yeah. Because in this case, if you write this program in C, line 3 is basically what we call dead code, because it's code. It is there. You can see it, but it will never execute because it is after a return statement. A return statement in C and C++ always goes straight to the end of the subroutine after itself. Okay, but in Visual Basic, it has a similar concept to return a value from a subroutine, but it does not go straight to the end of the subroutine after that, which makes sense in a way, but it does not make sense in many other ways. So in this case, because this class is mostly preparing students for CISP 360, we will use the behavior of C and C++, which means we do not execute line 3, we go straight to line 4. Okay, so let me just highlight this entire line with a different color because it is very important that we understand this. We go to background color, make sure we pick one that we can see. This projector is really nice because with the old projector, this will show up as kind of like dark brown. This is really nice. So on line 4, we do the usual thing that we do at the end of a subroutine, which means we deallocate this column. We copy and paste the header of this column, and then we change the formatting to include a strike through. And then we continue execution according to the return info cell, which means we continue on to line 5. Line 5 now looks like this, so that means we know exactly what we're supposed to print, which is the value of 12, and there's nothing else after line 5. We say post, we're done with the trace. So this is really an important example, and I'm glad that someone asked this question, because otherwise I would not have talked about it. But once again, the behavior depends on the programming language. In some programming languages, it behaves this way, and in some other programming languages, it will actually continue to execute and give you the print statement on line 3. Now, do you think something like this, the compiler should be able to check and tell you, hey, something is not right here. This code that you put after the return statement will not execute.
Probably won't even see that line.
Well, it does see that line, and unless you turn on all the warnings, and I think you even have to turn on optimization, it does not give you a message. Now, in this case, it's not a big deal. In this case, this program is nothing more than a test program, so it's not a big deal if we don't get to line 3. But what if you specify some additional code, after a return statement that is actually important? Well, then those instructions won't get executed. If the compiler doesn't give you a warning that those instructions or those lines won't get executed, then you'll be scratching your head because your program is not doing what you think the program should be doing. So this is something that I can also illustrate is how do you convince the compiler, which is a translation tool, to go from a C program to the language that the processor actually understands. You can actually make it complain more. than the default amount. And in this case, complaining and nagging is good. Okay? So let's go ahead. I'll just illustrate this. This is obviously out of the scope of this class, but I think since most of you are moving on to the next CISP360 class, this will eventually be useful. And since it's all being recorded, you can always kind of go back and listen to the lecture again when you move on to CISP360. Oh, the other thing is we don't have CISP360 as a summer class, so I have seen the schedule already, so I know CISP360 is not offered in the summer.
Thank you.
Well, not on this campus anyway. Maybe another campus would have it offered. I do not know the offering from other campuses, so I cannot say for sure whether it will be available from Sac City or some other college. So I'm going to write a program that is equivalent to the program that I just wrote. Okay. And how did I call that subroutine?
Post return.
Okay.
Post return.
Post return. It does not take any parameters. All it does is to return a value of 12, and it prints a particular statement. There are several ways to do the print statement thing. I can do a put s instead. It's just printing we are here, and a line. And then now when you write a C program, you don't have anything. You don't have a concept of outside of the definition of every subroutine, of any subroutine, because everything that you write has to be a part of a subroutine. All the code, all the statements must be a part of a subroutine. So the question now is, if everything are subroutines, where do we start our execution? As it turns out, there's a very special subroutine called main. And the main is special because it is a subroutine that is implicitly invoked first. In other words, you can look at the operating system is the invoker or the caller of the main subroutine. So whatever you want to start with, main is the entry point of your code. So now we can go ahead and print the value, the return value of post return. So this is how we specify that. You can see that the syntax is quite different from what we use in this class, but it really has the same meaning. And then we can use the compiler, which is GCC, which stands for GNU C compiler, to compile this program. So GCC-O to specify the output, the executable name, and we use just the same name here. And you can see the compiler quite happily compiles this program without any warning. So what is the behavior of the program if there's no warning? It just prints 12. It does not print we are here first. Okay, now that's a problem because according to the code, it seems like in a subroutine post return, it should print that statement, but it does not. It's because return goes straight to the end of a subroutine. It does not perform any additional lines in that subroutine. Okay, so now the question is, how do I convince the compiler to give me more warnings so that it can catch cases like this? And the option that you specify is -WALL. This W has to be uppercase, and then A, it stands for warn all. And give me as much warning as possible. So in this case, it gives me one warning, which says on line 12, column 1, control reaches end of non-void function. In other words, by the time we get to line 12, we won't be able to execute that line. Okay, so these are little tricks that you might want to, I'm sure most of you would have forgotten this by the time you move on to CISP360 because it will be in the fall semester. After the summer vacation, you come back, most of this stuff is out the window already, right? But in case you remember, then you can at least ask the professor, how do I make the compiler check for more stuff and give me more warning? Now, since this is a warning, it still gives you the program. You can still execute the program, but at least the compiler, which is the tool that does the translation, gives you a message and say, well, potentially maybe there's a problem here. Okay? Are there any questions about this? No questions? Okay. All right, if there are no questions, we'll just move on. But I will save this file. Sorry?
Oh, I was just gonna remind you that Tuesday you told me to remind you that I'd asked about sorting.
Yes, we'll deal with that too. And we'll do that in the context of subroutines. So we'll basically use subroutines to help organize the code.
Okay.
So this time we'll use, well, I'll just say post return as the file name because it explains what happens after the return statement. All right, let's go ahead and start with a new spreadsheet. And let me make sure I close all the other ones first. All right. What I'll do next is to write a subroutine that will, well, in the end, this entire program will sort an array. Okay, if you give it an array that is out of order, it will sort all the elements so that everything will be in order. We'll start with a subroutine called find min index. Okay, find min index, represents find the index of the minimum element in an array. So that's why we call it find min index. It will take a few parameters. The first parameter it takes is the array itself. Okay, I'm finding the index of the smallest element of which array. And it also needs a second parameter, which is the starting point. Okay, what is the first element that I should search from in order to find the least element? Okay, it will become apparent why we need this parameter because it doesn't seem to make any sense. An array is an array, and when you find the index of the minimum element, why don't we always start from the beginning? That's the question. But it makes sense, in this sorting algorithm. So I will explain that later. And then we have a local variable I, so that we can start. We don't really need local variable I. Well, I guess we need variable m for sure, which is the index of the smallest element. So what we'll do is we'll say m gets the value of b to begin with. In other words, we are assuming the first element, starting with b, is the least element already. Until I find something smaller than that, that's my assumption. And then we'll say while b is less than bar a bar minus 1, do the following. And we can also add one more line to make it slightly more efficient. B gets incremented by 1 right after that. And then the rest is something that we should have seen already in this class. It's just that it takes on a new form in this case because now it's inside the subroutine. So we'll say if a bracket m is the smallest element that I have seen so far, because that's the definition of m. M is the index of the smallest element, starting with b as we move down to the end of the array. So if what I think is the smallest is actually bigger than what I'm seeing at this point, then I better update what I think is the smallest. So m gets updated by b in this case. And then after that, we have to move b forward by 1 so that we move on to the next element. Let me fix the indentation first so that we can, let's finish the whole program, and then we'll take a look at the meaning of this program. And define sub. So here we fix all the indentations. 1, 2, 3, 4. Okay. So when you look at this program here, we first have, you first have to remember what m is. M is the index of the smallest element, starting with b up to this point, whatever that point is, in the execution of this subroutine. In other words, m is whatever you want to return at the end. B is given to you, it is the index of the first element of the entire array that you should consider and try to find the minimum of. So that means, sometimes we don't care about the first so many, elements in the array. The loop will exit when b equals 2 or when b is greater than bar a bar minus 1. Yep.
So if b is given the value of m, then doesn't that mean that the elements are going to get shifted? How do the...
No, it doesn't get shifted. We are not changing the array. All we are doing is to find the index of the smallest element starting from B. When we trace it, we'll see what it does. Okay, we'll trace this algorithm or trace this subroutine on its own first before it is used by another subroutine. And this statement here says, if what I think, okay, this part here is what I think is the smallest element, but if what I think is the smallest element is actually bigger than the element that I'm looking at right now, that means what I thought was the smallest was not actually the smallest. And that's why we have to update what I thought was the smallest so that it becomes the smallest that I have seen up to this point. When we get out of the conditional statement, we're just moving on to the next thing, the next element in the entire array, so that next iteration we'll be looking at the next element. When it's all done, we just return M. Let's go ahead and just trace this one first, just so that we know what it does, or it becomes more clear of what it does. And all we're going to do is to say print, invoke, find, min, index. We supply an array to A. In this case, we can use array X. Specifies parameter A, and we'll start with element, let's say 2, and that's it. Those are the only two parameters that I need to supply. So B2 will specify parameter B like that. So this is the sample program. Let me save it first. And I'll save this one with its own name of find min index. And in a new window, we'll go ahead and trace it. In this case, I do need to supply the global variable x, which is an array. So we'll start with x here. X bracket 0 is 2. X bracket 1 is 3. X bracket 2, let's say this is 7, and X bracket 3 is 2 again. 2 doesn't work well. Let's make it 6, and X bracket 4, let's make that 8. Now, this is just an example to illustrate what this particular subroutine is going to do. So there will be more after this. Okay, that's my precondition. I have one global variable, which is an array. It is initialized already like this, and we want to find out what value is going to be printed. What do you think will be printed? According to what we just said about the algorithm, if you just kind of run the algorithm in your mind, what do you think will be the value that we should return from the subroutine?
2.
It should return 3. Okay, it should return 3 because starting from index 2, the smallest element is actually the one with the index 3 because it has the smallest value of these 3. Okay, so we'll go ahead and run the algorithm and see whether it is doing exactly that. We start on line 15 and we perform the invocation. The invocation needs a return info in this case because we are coming back to line 15 to finish the print statement. Then we need to supply the parameters. We have parameter A, which is a reference to the array. We have parameter B, which is really just saying, where do we start looking? In this case, we start looking from the index of 2. A is an alias of a bunch of columns. In this case, it is an alias of column C all the way to column G because array X has 5 elements. Are we doing okay so far with the setup of the parameters? Oh, I missed one thing. What did I miss? I missed one thing. I have to allocate one more column for what? For M, which is my local variable. Okay, it starts with an unknown value. Yep.
How did you get the value of 2?
Because the invoke statement passes the value of 2. Yep. Okay. So now we go into the subroutine. At this point, we don't really need to look at the other stuff. We can get into the subroutine starting on line 5. And let me see. Since we're only tracking the subroutine, I can make the screen a little bit wider because we don't really need to look at line 15 anymore at this point. On line 5, I copy the value of b to m. B has a value of 2, m will now also have a value of 2. On line 6, I increment the value of b to 3. Oops, wrong place. There you go. On line 7, we perform the comparison. On line 7, we are checking the condition of the loop. B is less than bar A bar minus 1. Is that true or false?
It's true.
Okay, let's find out what is bar A bar. Okay, A is referring to column C to column G. Column C to column G is an array of how many elements?
5.
5 elements. And 5, oh, I think I got the algorithm wrong here. It is just bar A bar without the minus 1. Sorry about that. Okay, but the result is still the same, at least in this case, but the loop will exit too early if I did not fix it. Okay, B is less than bar A bar is true. We go into the loop here. Go to line 8. Is the condition on line 8 true or false? In other words, A bracket M is greater than A bracket B. Is that true or is that false? M is 2, B is 3. So we are comparing 7 to 6. Is 7 greater than 6?
Yes.
Answer is yes. So we have to go into the subroutine on line 9. Line 9 doesn't really do anything that's fancy. All it does is to copy B to M. B is 3, so now M is 3 as well. We get out of the conditional statement. We go to line 11. Line 11 is just adding 1 to B. B goes from 3 to 4. And then we go back to the beginning of the loop. At the beginning of the loop, on line 7, we ask the question, is B less than bar A bar? Bar A bar is 5, B is 4, 4 is less than 5 is true. We move on to the next line. We go to line 8. Line 8 asks, is A bracket M greater than A bracket B? M is 3 in this case, so we are looking at X bracket 3. A bracket B is A bracket 4, so we are comparing 6 to 8. Is 6 greater than 8?
No.
No. So the answer is false here. We skip over the entire conditional statement. We go to line 11. Line 11 is going to add 1 to B. B goes from 4 to 5. Whoops, wrong row. It's hard to align it. Okay. Then we go back to line 7. Line 7 is asking, is B less than bar A bar? The answer is false because B is 5 and bar A bar is 5 as well. Then we get out of the loop. We go to line 13. Line 13 is returning M. The value of M is 3. So we copy and paste the return info cell, change the question mark to 3, and then we are done with the return statement. We go to end define sub here on line 14. And all it does is to indicate where we're supposed to go back to, which is line 15. And then we deallocate the columns that we allocated earlier. So we copy and paste the headers, change the format to include strike through, and then we continue execution on line 15. When we continue execution on line 15 here, line 15 is now fully resolved. We know what value we are supposed to print. We will just print a value of 3, and we are done. Okay. Are we doing okay so far with the meaning of this particular subroutine? Okay. So the next question is, how do we use this subroutine for sorting purposes? Okay. The idea is something like this. You have a stack of cards that is not sorted. So what you do is you run through the entire stack of cards. You find the card that is the smallest. You pick that out. You put it on a separate stack. Okay. With the remaining portion of the original stack, you do exactly the same thing. You look for the smallest one, you pick that out, you put onto the next stack. So the stack that I'm creating will be sorted because every single time I'm just picking the smallest card from the original stack. Is that right? So I can keep doing this until the original stack is empty. Then the new stack will be all sorted. But that means we need 2 arrays in order to do the sorting. But what if I tell you that I have the same stack, except I put a little bookmark, at a certain point to separate the portion that is sorted versus the portion that is not sorted? Then I can actually combine the second stack, which is the stack that I'm creating, to the original stack. I just have to remember to move the bookmark along so that I can still remember which part of the stack is already sorted and which part is not sorted. And that's what we are doing here. This is the mechanism, this is a helper function, so to speak, so that we can accomplish what we want to do. Okay. Are there any questions about this algorithm at this point? If there are no questions about this algorithm, I'll go ahead and expand this program, and this time I will save it under a new name. We'll call this selection sort. Because this time we'll actually finish the entire sorting algorithm. And to do that, we have to continue to write the program. And in this case, we need swap. Swap is requires a local variable t. Oops. Okay, let's define the parameter first. Pass by reference x, pass by reference y, local variable t, and at this time we should be fairly familiar with the mechanism of swapping already. T gets x, x gets y, y gets t, and we find sum. That's the swap subroutine. So we're not going to spend too much time on the swap subroutine in this case because we already know how it works. And then the last one is to select the sorting algorithm. We'll just call it sort. Okay? Sort will require the array that we want to sort. It will require one index parameter, which is I, and it will require, let's just make it like this, okay? I can make it work, with only 2 parameters like that. Excuse me, the second one is actually a local variable, not a parameter. And this is what we'll do. We'll say I gets initialized to 0, while I is less than, this time it is bar a bar minus 1. Okay, I know for sure this time it has to be minus 1. And then the next one is kind of interesting. I'll skip that line first. We'll just go to I get I plus 1 because we do have to move on to the next item. And then we'll come back and talk about this line here. This line is going to be the combination of a whole bunch of stuff that we know already. So we'll say invoke swap. What do we need to supply to swap? We need to supply 2 parameters, both passed by reference. One is to supply to x and one to supply to y. The first parameter is going to be easy. I'll just say we supply a bracket I to parameter x. Now this is a new concept this is a combination of concepts that we haven't seen before. It's combining the concept of array indexing with the concept of passing by reference. Would that work? Well, the question is, does an element of an array occupy a column so that I can pass the reference of that column along to the parameter? That's the question. Well, every array element occupies a column, so we don't have a problem with this concept. We are just passing the reference of that column along to the by reference parameter. The second one is about the same thing. We're passing the reference of another element of this array to y. The question is, what are we going to put inside the square brackets? As it turns out, we can. Now, what is the requirement of something that we put inside the square brackets? What is the only requirement? Well, there are 2.
Does it have a column?
Hmm?
It needs to have a column.
It needs to have a column. Well, not the thing inside the square brackets when we do indexing. What is the requirement of indexing?
It has to be,
Has to be in the array.
It has to be an integer. Starting, what is the least value of that integer? 0. And what is the largest value of that integer? Bar a bar minus 1 in this case. So it can be a constant, obviously. It can be just 0, 1, or whatever. It can be out of I, just like in this case. Can it be the return value of a subroutine? If the subroutine returns an integer that turns out to be within the right range. Yes? Okay. So which subroutine do you think I'm going to use to supply the value for this index? Find min index. Okay, so I'll use find min index to do this. Okay, so this is where things really get kind of ugly because I can say invoke find min index, I have to supply the array to that subroutine. I will pass A along. And then what do you think I will pass along to B? Remember the row of B? B defines where in the array am I going to start to look for the least element. That would just be I. Okay, that's just going to be I. And I need one close parenthesis to end the invocation itself. And I think that's it. That is really, the whole thing. And of course, fix the indentation here. This is selection sort. I just have to fix everything else by saying and define sub. And outside here, I have to say invoke sort. And then this time I pass array x to parameter A. That concludes the entire sort subroutine. All right. Now that does look kind of convoluted, doesn't it? Because on line 28 particularly, we have two invocations. One is the inside invocation, and one is outside, which is the swap subroutine. We're swapping something around. So the question now is, what does it do exactly? And I think these parentheses are not really required, so I'll just take out the parentheses that are not needed. Well, to trace this program is going to be quite painful because it's very, very long. So instead of tracking every single subroutine, I'll focus on subroutine sort itself. I will not track down, a swap. I will not track down find min index. I'll just say what they will do, and then emulate the effect of those two subroutines. And here we go to the save first, and then we go to the other window to do the trace. Go ahead and delete everything up to here. And then this time we start execution on line 32. Line 32 is going to call sort, which is pretty easy. We set up return line number in this case because sort does not return a value. So that makes everything kind of easy because it just returns to post. And we also have to tell it what is parameter A. Parameter A is a reference to array X, which means it is now an alias of multiple columns, column C to column G. That we have seen already too, not too difficult either. Then we go into the subroutine and we start execution inside the subroutine. Oh, I forgot one thing. I forgot my local variable I, which starts with an unknown value. Then we go into the subroutine starting on line 26. Line 26, it will initialize I to 0. Then we go to line 27 to check whether I is less than bar A bar minus 1. Is that true or not?
Yes.
Okay, bar A bar is 5, 5 minus 1 is 4, 0 is less than 4 is true. We go to line 28. Now this time, that's the ugly part, right? What is line 28 going to do? Well, let's go find out what we are actually going to do in this case. What do you think find min index is going to return in this case? In other words, out of the entire thing, remember I is 0, so we are starting from the beginning of the entire array. If you look at this portion of the array, which element has the least value? X bracket 0. So that means it will return a value of 0 because we are returning the index of the element, not the value of the element. So it returns a 0. Okay? So when you look at this whole thing here, it becomes we are swapping A bracket 0 with A bracket 0. Well, swapping A bracket 0 with A bracket 0 really doesn't do anything. Okay? It's not harmful. It is a waste of time, but it is not harmful. So we'll just go ahead and do that. Okay, so on the first time we execute line 28, nothing really happens to the array, but I'll just put 2 here to remind ourselves that we are swapping that element with itself, which really does not really do anything. Okay, so it's equivalent to a null operation. Then we move on to line 29. Line 29 is going to add 1 to I becomes 1. We go back to the beginning to line 27. We ask, is 1 less than 4? The answer is true. We go to line 28 again. Now this time when we go to line 28, remember I now has a value of 1. So the first thing we want to do is to find out what is find min index going to return when we start from the first element, when we start with element 1 instead of element 0 of the array. So the question is basically asking what is the index of the smallest element of this portion here?
Bracket 1, 1.
It'll be the 3 here, okay, and it has a value, it has an index of 1. So find min index returns the index of that element, which is 1. What is I? I is 1 as well. So that means we are swapping the element, x bracket 1 with x bracket 1, which does not really do anything useful. So that's all done. Then we move on to line 29. We add 1 to I. I goes from 1 to 2. We go back to line 27. Oops. Line 27. And I is now 2. 2 is less than 4 is true. Okay? We go to line 28 again. This time it is more interesting. Because this time when we go to line 28, we still have to do the same thing. We have to invoke find min index to find the index of the smallest element, but this time we start with element 2. So the question is, which element has the smallest value in this case? Okay, so it will return 3. Now since invoke find min index is returning 3, this time we are swapping x bracket 2 with x bracket 3, because I has a value of 2 and the return value of find min index is 3. So the effect of this line 28 is going to exchange these two values. Are we doing okay so far? I'm not tracking down all the subroutines. I'm just emulating the effect of the subroutine so that we don't have to waste time to do all that stuff. So now we have this one being 6 and this one being 7. Okay? And then we go to line 29. Line 29 is going to add 1 to I again. I now becomes 3. Then we go back to line 27. I, which is 3, is less than bar A bar minus 1, which is 4, is true. This is the last time, this is the last iteration. We go to line 28. Line 28 is now going to ask, of these two elements, okay, of these two elements, which one has the least value? 3. It returns 3. 3 is the index of the one that has the least value. And I is also 3, which means on line 28, we'll swap x bracket 3 with x bracket 3 itself, which is doing nothing, but I do have to indicate that something is going to happen to column F. Then on line 29, we add 1 to I again. I becomes 4. We go back to line 27. 4 is less than 4 is false. We get out of the loop. We go to the end of the subroutine on line 31. We deallocate the columns. And don't leave just yet because there's one big important point I have to make at the end of this. So let's go ahead and finish this part first. And then we go back to post and we are done. Now someone can say, but Tech, something is not right here because we only made sure that the first 4 elements out of an array of 5 elements are sorted. We never did anything to the last element. We never invoke find min index on the very last element. Isn't that wrong? Because why is it not wrong?
Because it's been evaluated each time. It's not the least, and so you already got the 4 least numbers to the 5th.
Mm-hmm.
Out of all of them, so it no longer needs to be evaluated.
Exactly. It's called a pigeonhole principle. Okay, if you have if you have 5 values that you have to sort. So remember the 2 stacks of cards? If I have already picked out the 4 cards out of the original stack, put it onto the second stack in a sorted order, what do you know about the 5th one?
It's the max.
It has to be the maximum because it was not picked from the first 4 times that I picked the minimum, right? So as the largest element, I don't have to care what the value is because it has to go on last anyway. And that's exactly why I can stop one iteration earlier Because it's not wrong. It is not wrong here. If you say if while I is less than bar a bar, the algorithm is still correct. It is just that the last iteration is guaranteed to swap the last element of the array to itself. It's, in this case, in this particular example, if I change the values a little bit, if I make x bracket 2 8 and x bracket 4 7, you will actually see one more swap operation at the end. Okay, I just made it this way so that it does not happen in the end. But the algorithm is actually correct. It will take a lot of time to track it down, because the other subroutine also has a loop in it. So it will just. That's why I just kind of simplify the whole thing to illustrate how it works in general. Okay. Now, one more thing. I know you guys have to go to your next class. The this is called the selection sort algorithm. Is not the most efficient way to do sorting. Okay. So when you have to find an algorithm to do sorting, do not use insertion sort. It's just easy to understand, but it's not efficient. I'll see you guys on next Tuesday, and don't forget to do your homework.
So they